Usually in motorcycles, engines have the cylinder in vertical, horizontal, or inclined oriented. Single-cylinder engines require a larger flywheel and a heavy-duty gearbox than multi-cylinder engines. Small single-cylinder engines are cheap to build and maintain, and are suitable as cheap utility motorcycles. Most of you would have seen vertical and horizontal engines on bikes. Many among you would have wondered about the reason behind a particular orientation. So what do you think? Does the engine position matter? Some says placing the engine, whether it is vertical, horizontal, or inclined, has a very important role in bike's efficiency and its performance. Or it is based on the design of the chassis of the bike, and others says cost is the primary reason. But which is correct? Do engine orientations really matter? People generally have misconception about this topic. So in this video we will compare all types of engine orientations, depending upon different parameters. So first let's understand about each engine differently, and then we will compare them with one another. Let's start with horizontal engine. A horizontal engine is a piston engine, where the cylinders are located on side of a central crankshaft. The first horizontal engine was built in 1897 by Carl Benz, and these engines have been used in aviation, motorcycle, and automobile applications. Horizontal engines have the lower center of gravity than the vertical engine, and it gives a smoother ride and reduced vibration. The most horizontal engine frames are designed to provide more space and stiffness. Also, horizontal engine interferes less with the frame design, making it possible to create a frame of short, straight, and lighter. Generally, most low-capacity budget bikes don't use pressurized lubrication system to supply engine oil equally all over the engine area. That's why the engine is placed horizontally. The horizontal engine uses a splash-type lubrication system to lubricate the engine. In this system, the dipper is attached to the connecting rod. It picks up oil from the reservoir and spreads it across bearing surfaces as the piston travels through the cylinder. Horizontal engines offer several advantages for motorcycles, including a low center of mass, low vibration, suitability for shaft drive, and even cooling of the cylinders for air-cooled engines. Generally, horizontal mounting of engines will help to remain close to the ground, and so that lowering the center of gravity. With this orientation, better stability can be achieved. But in bikes, its presence is more towards reducing the size of the frame and thereby reducing the overall cost than increasing the stability. One of the most serious disadvantage is that due to their horizontal position, the part of the piston which is near the ground gets weared off soon compared to the other side. This wearing effect greatly reduces the efficiency. If you have any horizontal engine bike, then let me know in the comments. Vertical engine. An engine in which the piston moves vertically up and down and the crankshaft is usually below the cylinder. Engines, such as the typical inline 4 and 6-cylinder models, operate in a vertical straight line with the pistons running straight up and down as the engine rotate. Most of the people believe that the vertical engines are more powerful, but is a pure misconception. When the cylinder is in the exact vertical position, total weight of the cylinder comes into the action, and this would slightly reduce the overall efficiency. The engine on a high-end bikes are inclined forward, and in some bike reverse inclined engine can be fitted. Reversed inclined engine means that the engine is tilted towards the back. The longer swing arm provides greater stability to the bike, while the shorter wheelbase makes it a very agile. The reversed inclined engine makes it quite advanced. The main reason for the inclination is that the area in which the piston moves becomes inclined instead of dead vertical. When the area in which piston moves is inclined, more surface area is occupied by the engine oil. As I said, inclination could be forward or backward. Generally, most of bike has the forward inclination, because at the time of hard braking, all the momentum goes forward, and if the engine is inclined backward, all the engine oil will suddenly move in opposite direction, leaving more space for friction, which may stall the engine and lock the rear wheel. These are some factors need to be considered while placing the engine in bike. Which has more power? The power produced by the engine is nothing to do with the engine orientation. Whether the engine is mounted horizontally, vertically, or inclined, the effect of gravitation remains same irrespective of orientation of engine. That means Earth's gravity supports the downward movement of piston, and hence adds up to the power. But don't forget that the same gravitation opposes the piston's motion when the piston moves upwards. Hence the total effect of gravitation remains negligible. The horizontal engines have lower center of gravity as compared to the vertical engines. The lower center of gravity provides more stability to the vehicles. Also, in horizontal engines, piston reciprocate in the same direction as that of the vehicle motion, hence those vehicles experience less vibrations as compared to vertical engines. Space is a very important factor in arrangement of engines. The bigger engines generally have fuel pumps and cooling systems, which makes them bulky, and hence they cannot be accommodated properly inside the frame horizontally. The lower cc capacity engines, for example 100 cubic centimeters engines, are smaller in size and hence can be easily mounted horizontally on frame. The horizontal fitment of engine provides good space below the fuel tank, and hence utility box can be fitted easily. In horizontal engines, piston always rests on one side of cylinder. This increases the chances of wear and tear of piston rings and the cylinder wall on downward side. The piston in vertical engines remain straight and do not rest upon any specific side, hence it do not cause wear and tear. The horizontal engines are better aligned with the air flow direction and hence get cooled easily. The most of the parts of the horizontal engines are exposed to the air. This adds up to the cooling by air convection. On the other hand, the vertical engines are not completely exposed to the moving air. That's why they have poor chances to be cooled by air. Balancing. When you design the crankshaft piston assembly, it needs to be balanced for less wear and vibration. It is easier to do so in vertical engines than horizontal engines. Lubrication. Horizontal engine need to take an extra effort to lubricate the engine. It is clear that horizontal engines are more stable, since they lower the center of gravity of motorcycle. When the cylinder is in the exact vertical position, total weight of the cylinder comes into action, and this would slightly reduce the overall efficiency. The best possible arrangement would be of inclined orientation. The inclined engines are also easily accommodated inside the frame, and their exposed area to flowing air also increases a bit. Hence most of the higher cc engines are fitted on frame in inclined position. Inclining the engine with vertical will lower the center of gravity. The weight of the cylinder gets divided into horizontal and vertical components, and so this will thereby increase the overall efficiency compared to the exact vertical position, which will ultimately provide stability to the vehicle. I hope you guys enjoyed today's video. What do you think about these engine orientations? Let me know in the comments. And if you don't know what type of V engine is used in bikes, then click this video and find out.